Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video, we will find the relation between electric field and the potential gradient. So the title is Field and the Potential Gradient. Now in this video, we will consider the same example that we considered in the previous video. So here this is the positive charge plate and the lower one is the negative charge plate, and I'm going to consider the test charge at point A which is present between these two plates, and the test charge is this Q0, and we know that the test charge is positive. The charge on this Q0 will be positive, and there will be the force of repulsion between this Q0 and this positive plate. Therefore the Q0 will move from this point toward this point, which is point B. Now the Q0 will come here. So how we will bring this Q0 again to its original position? Some external force will be required, some external work done will be required to bring this Q0 again to its original position. So that work done from the point B to point A is given by the force exert on this unit test charge to bring that from the point A to point B, and multiply the distance covered by point charges. So here this is the equation for the work done, and this is labeled as equation 1. And now we know from the electric field intensity and the formula electric field intensity, and the formula for electric field intensity is equal to the force per unit test charge. In this case we can find the value of force, which is equal to F E and Q0. So let's this label as equation 2. Now put equation 2 in equation 1. The equation 1 become equation 1 implies that the work done from B to position A is equal to F, and instead of F I will write its value, which is equal to electric field intensity and Q0, and this del R comes its own position. So this is the equation for work done, and this work done is actually the change in work, the work from position, the work done to bring the charge from the position B to position A can be written as the change in the work, which is equal to the electric field intensity Q0 and del R. Now this is the equation 3. From the previous video we know that del W is equal to minus Q0 del V. This equation has been come from the equation that the change in potential is equal to the potential difference is equal to the work done per unit test charge. Okay, so this is now labeled as equation. This is equation 4. Now compare equation 3 and 4. The right side of the left side of the equation 3 and equation 4 are same, therefore the right side of this equation will also same. So the right side of the equation 3 is E, Q0 and del R, and the right side of the equation 4 is minus Q0 del V. The Q0 is cancelled with this Q0, and that equation become E del R is equal to del V. It implies that E is equal to In this case, this is minus del V. In this case, E is equal to minus del V by del R. And this is the relation for the electric field and the potential gradient. This is the potential gradient. So here, this is the final equation. This is the final equation. So here, this is actually this term is the potential gradient, and this is the electric field. It means that the electric field is equal to the negative of the potential gradient, mean the change in potential with respect to the distance del R. So this is the final relation for the field and the potential gradient.